Hello and welcome to class. This is Mr. Michael Zanata here. Today we'll be continuing our study on definite integrals. We'll be rounding up today. Over time we've had to look at how to solve or evaluate definite integrals of functions, and for today we'll look at how to evaluate definite integrals of trigonometric functions, as well as some other common functions that you get to see every now and then. Alright, in the last video we looked at the antiderivative or the integrals of trigonometric functions and some other common functions. So in this video we want to look at how we can evaluate the definite integrals of some of those functions. And just like a quick recap, in the last video I made mention of you having the need, or there being the need for you to commit to memory or some of those integrals. For example, you should know that the integral of cos x with respect to x is equal to sine x, okay, and that the integral of sine x with respect to x is equal to x, right, is equal to minus cos x, and that of the integral of sec square x is equal to tan x, and all that. So I gave you like there are about like 6 or 7 trigonometric functions that I gave you their integrals. So, but the basic ones are usually these that you have on the screen: cos, sine, and sec square x. But that does not mean that you cannot go ahead to also have knowledge of the others. So making use of this, also in that video we looked at the integral value of some common functions, like the integral value of your a raised by x with respect to x still gives you e raised by x or c, and other functions. Okay, so let's go to the chase. We have want to evaluate the definite integral of some trigonometric functions. First one, let's start with, let's say we want to evaluate the definite integral we have the upper bound of pi over 3 and the lower bound of, say, pi over 6 of the function cos x with respect to x. Okay, so we want to evaluate this, the definite integral of your cos x with the upper bound of pi over 3 and the lower bound of pi over 6 with respect to s. Just like we looked at in the other videos, it's the same way. You have to integrate the function that you have. Then when you get the answer you get, you plug in the values of your upper and lower limit, of which you will subtract the lower from the upper limit, and then evaluate or simplify as the case may be. So if we want to solve this, we will first of all have to find the integral of cos x, and that is where the knowledge of the last class comes into play. The integral of cos x is equal to sine x. So that's the first thing that we'll do. When we integrate cos x, that will give us sine x. And as you know, because we are solving with definite integrals, we don't need to add a plus c. However, we need to add our boundary conditions. So we still have a pi over 3, then the lower bound of pi over 6. Okay, we'll have that. So let's continue. The next thing is for us to plug in the values, these two values, the upper bound of pi over 3 and the lower bound of pi over 6 inside this x. Okay, we'll have to substitute those values in x and evaluate. Remember, we are going to connect them with the subtraction, the minus sign. So this changes to give us sine pi over 3 minus sine pi over 6. Remember that your pi has a value of 180 degrees, okay, the rad. So you have, so this sine pi over 3, that's 180 over 3, that will give us 60 degrees. So this will evaluate to give us sine 60 degrees minus, and then pi over 6, that's 180 over 6 will give us 30 minus sine 30 degrees. That is what they will evaluate to give us. Then solving sine 60 degrees is equal to, by your trig identities, your sine 60 degrees is equal to root 3 over 2 minus, and then sine 30 is equal to 1 over 2. And altogether this evaluates to give us root 3 minus 1 all over 2 as our answer. Or you can choose to find the value using your calculator, root 3 minus 1 all over 2, and that would evaluate to 0.366 and thereabouts. Okay, so that's how we can solve something like this. The integral of cos x having the upper boundary condition of pi over 3 and pi over 6, that will give us 0.366 or root 3 minus 1 all over 2. Okay, so let's look at next example. Let me quickly clean up this. Okay, so let's say we have another example here. Let's say we want to evaluate. We have the integral of pi over 4 as and then the lower limit of 0 for the function sine 2x with respect to x. Alright, we have this, want to integrate sine 2x with respect to x, having the upper boundary condition of pi over 4 and then the lower boundary condition of 0. Let me write that very well. Alright, so the same process, we'll repeat that. The first thing that we need to do is to integrate our function sine 2x. Then you can recall from the last video that when we integrate sine x, what we're going to get is minus cos x. And when we integrate sine 2x using our chain rule, what we are going to have is minus cos 2x over 2. That's what we're going to get when we integrate this function sine 2x. When we integrate it, we're going to have minus cos 2x over 2. And of course, we have to attach the condition. So we have pi over 4 and then 0. So here, having done this, what we need to do next is to plug in the values of the limit inside the given integral. So our pi over 4, that's 180 over 4, that will evaluate to 45 degrees. So what we're having here is minus cos in bracket 2 times 45, because our x in this case is 45. When you evaluate pi over 4, 180 over 4, that will give 45. So you have that all over 2 minus then we'll evaluate for 0 now. We have cos in bracket 2 times 0 all over 2. Okay, this is what we have. Evaluating this 2 times 45, that will give us 90 degrees, and cos 90 degrees is equal to 0. So this whole expression here evaluates to 0. So what we're having is 0. So we have 0 for that part, minus, then we have a 0, minus, then for this expression here, 2 times 0 is 0, and cos 0 is 1. Okay, so your cos 0 will evaluate to 1, and this whole expression here will evaluate and give us 1 over 2. However, okay, oh, there is a mistake. There is a minus. Remember that our cos has a negative value here, so minus into minus will give us a plus. So here it changes to plus, just like from our original integral. There is a minus sign going with our cos. Okay, so when that minus, this minus is from the formula, while this minus from the formula, while this is from the integral, as the integral of sine x, giving us minus cos x. So minus into minus will give us a plus, and we're having 0 plus 1 over 2, and that will give us 1 over 2 as our answer, which is can also evaluate to 0.5. So that's how we can solve something like this. Okay, let's look at another one now. Okay, so let's say we want to evaluate the integral of, you have your integral of 1 over x with respect to x, having the boundary conditions of your of a and 1. Okay, so we have this to be the boundary condition, the upper boundary, and then the 1 lower boundary of 1 over x. Now if you remember in the last video, we learned that the integral of 1 over x is equal to your ln x or ln x. Okay, so when we integrate 1 over x, which is the first that we have to do, we get ln x. Alright, and of course we won't add a plus c, because we are dealing with definite integrals, but we need to add the conditions. So we'll still have a and 1 and 1 here. Alright, now the next thing for us to do is to put in the value of our boundary conditions into our integral function ln x or ln x. So when we do that, we're having ln e minus ln 1. That's what we're having, ln e minus ln 1. And at this point you would have to know that the value of your ln e or ln of e, ln e is equal to 1. So you have to know that the value of ln e is equal to 1, and the value of ln 1 or ln 1 is equal to 0. So this expression here evaluates to 1. We have a minus, while here ln 1 or ln 1 evaluates to 0. So we're having 1 minus 0, and that will give us 1. And this is how you evaluate an integral like this. These are common integrals that you see every now and then. Okay, let's take one more. Alright, okay, let's say we want to integrate the following function, the integral of your e raised to power 3x with respect to x, having the boundary conditions of 2 over 3 and say 0 for the lower limit. So let's say we want to integrate something like this. How do we go about it? In the last video we found out that the integral of our e raised power 3x will evaluate to e raised power 3x all over 3. Alright, so that's the first thing that I want to do. We'll have to integrate this function e raised power 3x, and when we integrate that, what we have is e raised power 3x all over 3. Okay, no need for r plus c. We'll have our conditions 2 over 3 and then of course 0. So we'll go ahead and substitute the values into the function that we have here. So substitute into this function that we have here. Alright, so going ahead, to have e raised power 3, then in brackets for our x, in place of our x we are writing 2 over 3. we have a 2 over 3, still all over 3, minus, then for the lower limit of 0 we also do the same thing. So we're having e raised power 3 into bracket 0, still all over 3. And then trying to simplify this, the 3 here cancels this 3. So what we're having left is e raised power 2 over 3 minus, for here 3 times 0 is 0, and then e raised power 0, anything raised power 0 will evaluate to 1. So e raised power 0 give us a 1 over 3. So we might leave our answer like this, or we can simplify further and using our LCM to combine, join them together. What we have is over 3 e raised power 2 minus 1. So this or this one here or this here, either of them can serve as your answer. Alright, so this is how we can solve for integrals, or integrals of some trigonometric functions, alright, and other common functions. So it's for you to look at it, understand what we are doing, and then try to solve the assignments that I'm going to write out now. Alright, okay, so let's let me clean the board and write down some assignments that you can do in order to solidify your knowledge. Okay, so you're going to evaluate for me the following definite integrals. So we have assignment. So we have assignment on the board. So what I would want you to do for me is to try and evaluate the following function. Evaluate for me 1, definite integral of pi over 2, and then of course pi over 6 of sine x with respect to x. Alright, that's 1. For 2, you can also evaluate for me the definite integral, okay, of e raised to power 3x, having the boundary conditions of 1 over 3 and 0 with respect to x. Okay, then another one that I want you to try out and see how that works out is this here. Evaluate for me the definite integral 9, you have 4 of square root of x with respect to x. Now for this number 3, I want to give you a hint. Remember that your x square root of x is equal to x raised to power half. Remember that. It's a hint. So where you are solving for that, remember that your square root of x is equal to x raised to power half. So try this out, and then of course consult textbook and other reference materials and solve as many examples as you can. All that will help you to learn this topic even better or more than what we have looked at here. This is not exhaustive, but this will help you practice what we have taught in this period. Okay, so this is where we're going to end the class. For now, we have looked at the meaning of definite integrals. We've looked at what makes an integral a definite integral when it has the boundary conditions or the limits. We have looked at how to integrate definite integrals of some algebraic functions, and here we are looking at how to integrate definite integrals for trigonometric functions and some other common functions. Alright, that is what we've looked at. So just try to solve the assignments that I have attached and submit for marking and correction. So I'll be seeing you in the next class. Until then, stay safe, okay, and reach out to me if there is any need. Okay, bye for now.